Hi everyone, I'm CHENGZU. Today I'm going to introduce our poster, a blockchain-aided self-sovereign identity framework for the edge-based UAV delivery system. As the figure shown, the framework consists of self-sovereign identity and blockchain. Using the self-sovereign identity with public blockchain, anyone can issue a digital signed credential. Everyone can verify it. The issuer is the authority that can issue the verification credentials about any subject to the holder. The holder is a UAV owner who can receive verification credentials from the issuer. The verifier is the service provider that can verify the verifiable credential from the holder and store proofs of the issuer claims. The claims in a credential can be any subject, such as driving license. The presentation process drives the data from the VCs issued by issuer. Is temporal evidence presentation being encrypted so that authorship of the data can be trusted after the verification process. The data registry is performed by implementing the VC scheme, maintaining identifiers and public keys. Additionally, we illustrated the UAV delivery system's security assurance. The blockchain provides secure structure. The mock tree structure with hash value facilitates blocks to be constructed in order to pre-hash value always. The public key infrastructure scheme adopts encrypted data and provides secure protection to blocks. And the immutability of blockchain motivates miners to work on the largest chain. It enables the immunity feature for blockchain. And the use of digital signature enables a traceability feature for blockchain. And the fault tolerance of blockchain is used the consensus scheme, like a proof of work and proof of stake consensus scheme. They can achieve the Byzantine fault tolerance for blockchain. Supposing the attacks happen on one of the nodes in the network, the Byzantine fault tolerance can remove the impact of the fault nodes, and the operation in other nodes still can be worked. The self-sovereign identity is a method enable users to fully control their own digital identities in their digital wallet. It is composed with the digital identifier and the verifiable credentials. The individual user usually has a collection of identities and has full control of their own identities via the federal models. And the approach provides proof of identity for vulnerable people to access essential services such as enrolling in school, applying for a job. If the centralized database is attacked, the sensitive data will be disclosed. Our approach stores the data in a decentralized network to protect data security. And our work can generate a unique digital identity for each user. We compile the smart contract on the Remix. And Remix enables developers to build, deploy, and conduct smart contracts on the Ethereum platform. On the platform, we can use it for programming, like we use the Solidity language to compile the smart contract. The environment is a JavaScript virtual machine, which is used to deploy the smart contract. And we call the guest to implement our smart contract. As the figure shown, we set up 10 receivers are tested. The results show that gas consumption using the ultra-restricted approach is ascending trend when the data for each receiver is increased. In other words, the receiver processing higher data will lead to more gas consumption within the verification process implementation. As the figure shown, we further compare the transaction time between the face recognition task and the blockchain-based task with the self-sovereign identity scenario. The average transaction time with blockchain is always lower than the approach without blockchain. To sum up, in this paper we have proposed a seamlessly integrated self-sovereign identity framework with blockchain in the edge-based UAV delivery system. Specifically, the proposed self-sovereign identity is to optimize the UAV delivery verification process. Any blockchain technology is developed for the fit into the security consideration of the UAV delivery system. We customize the smart contract to implement and evaluate this framework. The performance evaluation result prove this work can efficiently verify user identity while the system security protect level is maintained.